What are acyl chlorides? Acyl chlorides are organic compounds similar to carboxylic acids, but with the hydroxyl OH group replaced with a chlorine atom. Examples of acyl chlorides are formyl chloride, HC+O+Cl, which consists of one carbon atom, and acyl chloride, CH3C+O+Cl, which has two carbon atoms. So how are acyl chlorides prepared? With such a close relationship to carboxylic acids, you would think they would be prepared from the corresponding carboxylic acids. Acyl chlorides are prepared from the treatment of carboxylic acids with phosphorus pentachloride or phosphorus trichloride or sulfur dichloride oxide. Let's look at the preparation of acetyl chloride from the corresponding carboxylic acid, acetic acid, using the three reagents. First, the reaction of acetic acid with phosphorus pentachloride gives acetyl chloride CH3C+O+Cl and phosphoric chloride POCl3 and hydrochloric acid HCl. The second reaction is a reaction of acetic acid, this time with phosphorus trichloride, to give acetyl chloride CH3COCl and phosphorus acid H3PO3. Notice in this reaction 3 moles of acetic acid are used to give 3 moles of acetyl chloride. The third reaction is the reaction of acetic acid with sulfur dichloride oxide, also called cyanide chloride, SOCl2, to give acetyl chloride CH3C+O+Cl and sulfur dioxide SO2 and hydrochloric acid HCl. This reaction, as you can see, requires heat for the reaction to happen. Let's look in detail at the mechanism of the reaction of acetic acid with cyanide chloride. First, the nucleophilic attack of the double bond on the cyanide chloride to form a complex CH3C+O+H, positive here because the oxygen has only 5 surrounding electrons and its valence electrons are 6 electrons, so 6 minus 5 equal the positive we write here. Then this oxygen is now also bonded to the cyanide chloride SClClO, and the negative here because the oxygen is surrounded by 7 electrons. 6 minus 7 equal the negative 1 we write over the oxygen. This complex contains the good leaving chloride ion. That is why this reaction is followed by the removal of the chloride ion, leaving the chlorosulfate group CH3C+O+H positive bond O bond S Cl+O. This compound is susceptible to the nucleophilic attack on the carbonyl, where the insertion of the chloride ion on the carbon occurs. Followed by the breaking of the bond between the carbon and this oxygen. This lone pair forms a double bond and the removal of the chloride ion leaving group. This gives us the protonated acetyl chloride, CH3, C double bond O, H, bond Cl. And this one gives us sulfur dioxide, S, double bond O from this side and double bond O from the other side. And this one is the chloride ion, Cl negative. The last step is the deprotonation of the protonated acetyl chloride by the chloride ion released in the previous step. The chloride ion takes away a proton, and the bond between the oxygen and the hydrogen breaks. So the result is a formation of acetyl chloride, CH3, C double bond O, bond Cl. And hydrochloric acid, HCl. Let's solve this exercise. Write a balanced equation using a structural formula for the organic compounds and state any necessary conditions to show the formation of propanol chloride from acetable carboxylic acid and cyanyl chloride, methanol chloride from acetable carboxylic acid and phosphorus trichloride, and pentanol chloride from acetable carboxylic acid and phosphorus pentachloride. To solve this reaction, we need to use retrosynthesis. First, let's write down the structure of propanol chloride. Propanol means we have 3 carbons. One of them carries the oxygen and the chlorine atoms, C double bond O and Cl. Then we attach this carbon to another 2 carbons, CH2 for the carbon to satisfy the octet rule, and CH3, another 3 hydrogens for the terminal carbon. By that we have 3 carbons, CH3, CH2, C double bond O, Cl. Now let's try to write the corresponding carboxylic acid. We write the propanol chloride structure where we replace the chlorine atom with a hydroxyl group. This gives us that the corresponding carboxylic acid is propanoic acid. Let's write the reaction. Propanoic acid reacts with cyanyl chloride. Using heat produces propanol chloride, sulfur dioxide, and hydrochloric acid. The second question, the preparation of methanol chloride using phosphorus trichloride, PCl3. First, we write the product methanol chloride, which means we have 1 single carbon. This carbon is doubly bonded to oxygen atom and singly bonded to chlorine atom, and attached to a hydrogen atom for the carbon to have 4 surrounding bonds. By that, the starting material should also contain 1 single carbon, doubly bonded to oxygen and singly bonded to hydroxyl and another hydrogen. You can see that the corresponding carboxylic acid is formic acid. Let's try to write the reaction. Formic acid reacts with phosphorus trichloride to give methanol chloride and phosphorus acid. Let's try to balance the equation. We have 3 chlorine atoms on the reactant side, so we multiply the product by 3. By that we have 3 oxygens plus another 3 oxygens gives 6 oxygens on the product side, so we need to multiply formic acid by 3 to have 6 oxygens on this side as well. From that, you can see we have 3 moles of formic acid react with 1 mole of phosphorus trichloride to give 3 moles of formyl chloride, which has the IUPAC name methanol chloride, and 1 mole of phosphorus acid. The third part of the exercise shows how to prepare betanil chloride using phosphorus pentachloride and the corresponding carboxylic acid. First, we write the structure of betanil chloride. 4 carbons, one of which is doubly bonded to oxygen, singly bonded to chlorine atom, and singly bonded to another carbon. Then this carbon needs 2 hydrogens, and this one as well. For the terminal carbon, it is attached to another 3 hydrogens. So the corresponding carboxylic acid is butanoic acid. Now let's try to write the reaction. Butanoic acid reacts with phosphorus pentachloride to give butanol chloride, phosphoryl chloride, and hydrochloric acid.